Hi and welcome to this video on time and memory complexity. In this video we'll be talking about them at a fundamental level, but before we go into that it should be really clear why are we studying about that. So in a general problem setting you have some sort of problem which gives you an input. You need to code a problem's solution so that you can get the desired output for the some test cases that are set on the platform. So these are the typical setting that you would be solving problem in. So the general flow that people follow is that you read the problem. You first of all understand what the problem is really wanting you to solve. You ideate the solution idea. You go in and implement that. You sometimes might get bugs in your code. So you try to debug your code. And then finally you go ahead and get your solution accepted. That's the flow that people follow. Now, in this flow, you might see that this reading part is pretty easy, right? You already know how to read a statement. You know how you can understand it and how you would be able to take out the gist of the problem, like what that problem is asking you to solve. This is the crux part, that you need to find a solution idea that will work for the problem, that will work for the inputs that are possible in the problem, and you should get the desired output. Now when you're trying to ideate a solution, there are 2-3 things that you need to think about. First of all, is your solution correct? Or you can think about correctness of your solution. So you might think of a lot of ideas that might seem plausible at the first glance, but again, when you think about that, there might be some cases in the input which might be giving wrong answers on those cases. So some ideas might not work correctly on all inputs. So you need to think about the correctness of the solution that you have thought of. The second factor that comes into play is the efficiency. Is your solution efficient? Will your solution be able to process the inputs that are possible for the problem in the given time limit? So this factor that we're talking about is the thing that would be solving in this problem. So once we have a grasp on time complexity and memory complexity, you would be able to decide whether the solutions that you design are efficient enough to pass the time limit and memory limit of a problem. Once you have your solution passing both of these, you need to just implement that in a language of your choice and then debug it if that is required and then get accepted. So this is the crux part that you should be learning as problem solving, and one of the main step of that is finding an efficient solution. So for efficiency, you need to understand whether your code will pass the time limit or not. And there will be some memory that is designated for your problem on the online judge or the platform that you're solving the problem in, whether that will pass the memory limit in that setting or not. So for this, you need to understand the concepts of time complexity and memory complexity. So now let's look what they mean. So time complexity actually means the number of elementary instructions that the algorithm or the code that you have written is executing for a given input. So it's not actually the time, like you don't have a nanosecond clock that runs up and you just measure how much time it's taking. It's actually the number of instructions that it takes. Inside the CPU, there is a fixed internal clock speed and the number of cycles that are needed by instruction, which all decide the total time it will take. But in algorithmic sense, when you think about a problem, when you're thinking about writing some code, you really look at the number of instructions that it requires. So now there can be many inputs, right? There can be many inputs. So which inputs do we look at? So for that, there are different kind of time complexities defined. There is something called best best case complexity, average case complexity, and worst case complexity. So as the name suggests, best case is like for any input, what is the best case that you can get. Like in some input, your algorithm might just return the solution then and there, and for some of them it might take a long time. So you take the best one of them, you take the average out of all of the cases that are possible as input in the problem, and in worst case you see what is the maximum time that your program can take. So if your program is going in an infinite loop, your worst case time limit is order infinity, or like it's an infinite time taking problem. But in that case, what's the time complexity that your program is taking depends on the input. So these are the cases that we define based on what input we are getting. Now, in most of the problems that you would be solving, you would be worried about these worst cases, because when you're solving problem on some online judge or in a contest setting, what happens is that the people who have designed the problem set test cases so that most of the solution fail or don't get past the time limit. So they will design this worst case for sure. So you need to work in a way that even the worst case is good for you. So this is the most limiting case, and so you need to be considering the worst case time complexity of your algorithm to decide whether that will pass the time limit or not. Now in a lot of problem, you are given test file. For each test file, you have test cases, and in each test case, you have some input. Okay. So you, in a lot of problems, you will be asked that there will be some test files in the backend. So these files are in the backend. Okay. So when you write a problem, you basically give your code, and the server runs it on the test files and then matches the output that you get. So in each test file, you can have some number of test cases. So when you are given a time limit in a problem, that's actually for this whole execution. So if in the input part you are given some test cases and then the input, the time limit given to you is the sum of all test case taken together. So all the test cases that are given an input should be able to be passed in the same time limit. So one file, one input file, one time limit. Next input file will get another slot of time limit. And inside that test file, there can be multiple test cases again, but the test cases must be handled, the sum of all test cases must be handled within the same time limit. So please bear this in mind, because a lot of people make mistake on this and code up a solution that works only for this input, but rather when they see a lot of test cases, this fails. So remember, whatever your code is taking as input, one complete execution of your code should take less than equal to the time limit given. Just to be safe side, it's less than the time limit. It should not be equal to. Okay. So now once clear on that, let's look into what these time complexities actually mean. Like how would you count about the instructions that are required in a program? Like that's really something difficult, right? Because suppose I give you a program, something like this, simply a loop I equal to 0, I is less than some input n. So you can take that this n is an input and I plus plus, and then you have for another loop j equal to 0, j is less than I, j plus plus, and then there is some variable that is defined globally. Let's just say it's defined over here, and then count is increasing in the instruction, and that's all for this loop, and then this loop closes, right? So let's say this is your some portion of your code, right? Now if you go ahead and try to calculate the time complexity of this, you might be thinking about, by the definition it means the number of instruction it takes, right? So let's just quickly try and formulate out the number of instructions. So this would take, so let's not take this one, I'm assuming that it's already initialized to 0. So this initialization takes 1, plus this loop runs n number of times, right? So this I plus plus works n number of times. Okay, I'm not taking these comparators. Also this is also an instruction that when you convert these into assembly level code, these are also taken into consideration, but for simplicity I'm not assuming that these are taken for now in complexities. Okay, again for the next rows you have this initialization as 1, and this j will move up to I number of times, right? I number of times. And then this will work a lot of number of times. So I goes from 0 to n minus 1 and j goes from 0 to I. So how many times do you think this loop is running? So this loop is running exactly I number of times, right? And this is running n number of times. So this sum count variable increment is actually showing up these many number of times. For the first time it's 1, then 2, then 3. When I is 3, j is also, j goes from 0 to 2, so count plus plus happens 3 number of times, and so on up to n, right? And this is simply n into n plus 1 by 2 using the AP summation formula, right? And again, this j plus plus also occurs I number of times, and I occurs from 0 to n, so this will also be another n into n plus 1 by 2, right? And this j equal to 0 happens n number of times, so this takes one instruction, but this will happen n number of times, right? Plus n, plus you have this n for the I plus plus, and then 1 for this initialization. So it becomes something like you can take n square plus 3n plus 1 if you reduce it. Okay. We are really not cared about the exact numbers, but the thing is that something like this, an expression comes up, right? This is the number of instruction runs that it will take when you are given an input of size n, right? So the number of instruction run actually depends upon the n, right? Now if you think about this, you have calculated it almost precisely. If you taking consideration the less than n, so that will happen exactly same as these I plus plus number of times. So as many times I plus plus happens, this gets tested. So you can take that part as well, because this is also an instruction, but for simplicity I have not assumed that over here. Now this is pretty difficult, right? If you have say 10 lines of code, doing this all calculation for each variable at every place is pretty difficult, right? So fortunately this can be done relatively easily using something called a big O notation, which expresses the worst case complexity of a function of n as n gets larger. So we want to address the time taken or the number of instruction run as n goes higher and higher, right? So we want to understand the asymptotics of the function. So that really means that as the n grows higher, what is the time taken by your program? So for that we use something called a big O notation. So complexity is an upper bound for the number of steps an algorithm requires as a function of input. So that's what we are trying to do. We want to find out an upper bound. And in big O notation, we denote the complexity of the function as something called order, in this notation, order big O of f of n. Okay. So which means that as the n grows up, so fn is the complexity of the code, that the number of instruction taken will be fn times some c plus some lower order terms. So if we want to think about this, like in this problem we had something of a form n square plus 3n plus 1, right? So as n grows up, n square grows relatively faster than n, right? So this starts dominating this pretty much after some, like if you take, even if you take 100 and all, if like plus 1 on this and plus 1 on this is pretty much drastic on this case, right? So this is the one that is dominating. So we define a simple notation like order n square, which basically mean that there is some constant time n square plus lower order terms, which is the number of steps, and as n is increasing, this n square is what is dominating our program, right? So this is what we mean by order notation. So to make the calculation and approximations of number of instruction needed for the program easier, we have introduced something called this order notation. And this order notation turns out to help us decide whether our solution is efficient enough to pass the time limits in the given problem. So we will look into this order notation in details in the next video.